So we're given the Earth. And we've got an object up here. And it's circulating around the Earth. We want to find the altitude above the Earth if we know that it takes 180 minutes for the satellite to complete a rotation. So we're going to need the radius of the Earth. Well, we may not, but we're going to get there. So let's look at it this way. We've got the radius of the Earth. And then our radius of our satellite is going to equal h plus the radius of the Earth. So the height of the satellite is going to equal that radius minus the radius of the Earth. The period T we're given as 180 minutes, but we want that in seconds. So we got to calculate that in seconds. It gives us 10,800 seconds. And Kepler's third law gives us this. It says that T squared is equal to 4 pi squared gravitational constant mass of the Earth radius. So we've got T squared is proportional to R cubed. That's Kepler's third law. So we can solve for R. R is going to equal T squared G, mass of the Earth, 4 pi, the cube root of that. So we're going to plug in our numbers. I'm going to get 10,800 seconds squared. G is 6.67 times 10 to the minus 11 Newton meters squared, kilograms squared. Mass of the Earth is 5.98 times 10 to the 24 kilograms. All divided by 4 pi to the 1/3. So I'm going to square that, multiply it by 6.67. It's 10 to the minus 11 times 5.98. 10 to the 24 divided by 4 times pi times pi. Oops. Make sure we keep our pi squareds in here. Now I get a number that looks like this, 1.18 times 10 to the 21st. And that will ultimately be in meters cubed. And that's to the 1/3. Now make sure I punch it into the calculator correctly. And I get 1.06 times 10 to the 7th meters. But we got to subtract off the radius of the Earth. And the radius of the Earth is 6.38 times 10 to the 6 meters. And I get 4,018 times 10 to the 6th meters. And then if you want, you can calculate G, because G is going to equal the constant mass of the Earth divided by R squared times mass. And so so that's G. So you can calculate G, or you can calculate the force due to gravity out there. So you can actually do that calculation. Okay. I think that kind of gets us where we need to be. So on Friday, we're going to actually start